Day 9 is about Venn diagrams. We're also going to take a look at set notation and something called mutually exclusive events. For the warm-up, on the poster on the wall, which I'll have up in class, I'm going to give you a sticky dot and I'm going to ask you to place it in the appropriate location. Do you like black licorice, chocolate, both, or neither? So I'll just put some dots in here to represent. Okay, so let's say that this was our class right here. And how many in this spot that like black licorice? There are 4. There are 2 that like both chocolate and black licorice. And there's 10 that like just chocolate. And then there's 1 that doesn't like either. So it will be our sample set and that we're going to use today to learn set notation vocabulary. So the first symbol that we're going to go over is called union, which means or. So for example, what's the probability they like a person likes black licorice or chocolate? All right, so black licorice or chocolate means that they can like black licorice, so this part right here, or chocolate, this part right here, or they can like both. So it's actually everything inside of here, inside the 2 circles. So we would add 4 plus 2 plus 10. And so if it's probability, they like black licorice or chocolate, we can say it's 4, 5, 6, so 16 out of, and there's 17 in the sample space. And then we could change it to decimal percent. All right, and looks more like an A. So it's an upside down U, and again, it means and. So if we have the probability like black licorice and chocolate, all right, and black licorice and chocolate would be an overlap of both. So we'd be looking right here, and that would be 2. So the probability they like black licorice and chocolate would be 2 out of 17 total. And then not, there's a few symbols for not. Let's make this red. You might see like the wavy line. You might see a line that looks like that. Oh, I should put the symbols right here. And so the meaning of that is not. So what's the probability they don't like? I don't know, let's just do don't like black licorice. Okay, so this is don't like black licorice. Okay, so if I were to highlight that area, don't like black licorice, it would be right here. And then it would also be like on the outside right here. I would color that in. And for this sample space, it would be 11 out of 17. So again, union means or, it's one or the other, both. Intersection looks more like an A, it means and, so they like black licorice and chocolate. And not means everything but black licorice in this example. Okay, sets. In math, a set is a collection of items or numbers. We often use Venn diagrams to organize sets. So set A is everything in A. Notice it can be an A and B as well, but everything in A is in that circle. And so we can write this set notation. You see this often on Delta Math too when we've been putting in answers that have, things that have more than one answer. You have these curvy brackets right here. And so everything in set A would be the 1, the 6, the 3, the 5, the 4, and the 7. And then in set B is everything in set B. It can also be in set A, so 4 and 7, 8, 2, and 9. So there's set notation. So here's some putting like both new things together. Set notation for the intersection of A and B would be 4 and 7. Union would be one or the other or both, so it's everything. So 1, 6, 3, 5, 4, 7, 8, 9, and 2. So or is everything. Whoops, that's not a very good curvy bracket. And the complement is everything on the outside, so not A. Oh yeah, here's another way to do complement, the little C right there. And so this would be 3, so not in A, so it'd be 3 and 9, but also 4, okay, so I should circle this, and then 7, 6, and 2. So there's an example of set notation in Venn diagrams using the symbols. Okay, so let's practice. So in class I'll have you fill this out. So the first one is how many or which numbers are in A and C? Okay, so A and C is where it overlaps. So A and C would be these two numbers right here. They're in both sets A and C, so 5 and 6. Okay, oopsies. A or C is the next one, and or means one or the other or both. So it can be in set A, it can be in set C, and it can be in both. So 1, 4, 5, 6, 3, 7. Okay, my curly brackets are not looking great. Let's redo those. All right, the next one is in A or B or C. So essentially it's everything but the 8 on the outside. So let's list all the numbers except for the 8. Oh, my curly brackets, okay. So it would be 1, 4, 5, 6, 7, 3, 9, and 2. Not in C. Okay, so everything not in C would be 1, 4, 9, 2, and 8. If it's an A and B, that's just the 6 right there. And then an A or B or C. Oh, so I did the other one wrong because the other one is what's an A and B and C. So this one was wrong. This one should have just been the 6 is in both of them. Whereas A or B or C is everything. So that's where I should have put all the numbers that are in A, B, and C. So the 1, 4, 5, 6, 9, 7, 2, and 3. Okay, so there's an example of set notation. Also with these Venn diagram vocab words, set notation vocabulary. Okay, the events to the left are mutually exclusive. What does it mean if events are mutually exclusive? And it means they can't happen at the same time. So you can't be a 9th grader and a 10th grader at the same time. So can you think of events that are mutually exclusive? So in class we talk about this. We might come up with things such as you can't be awake while you're sleeping. You can't drink and sneeze at the same time. Something like that. You can't have 2 first hours. So you can't have math and English first hour in the same semester. So mutually exclusive means they're totally separate from one another. And then we have complements, and we've talked about this before. It says you roll 2 die and add the answers. How can you quickly find the following probabilities? So the first one is, what's the probability the sum is not 8? So instead of counting all the ones that are not 8, why don't we just count the ones that are 8? Okay, so 8 would be right here, here, here. All right, that was pretty fast to count. That was 1, 2, 3, 4, 5. 5 out of 8, and there's 36 possibilities. So if we do 36 minus 5, that's much faster than counting all the ones that are where the sum is not 8. So you have a 31 out of 36 chance of getting something that's not 8. So that's using the complement. What's the probability that the sum is greater than or equal to 4? So instead of counting all the ones that are greater than or equal to 4, let's count all the ones that are 4 or less. So these are all 4 or less, and so the rest are greater than or equal to. So if we take 36 minus 1, 2, 3, 4, 5, 6, that's a lot faster than counting all the other ones. So using the complement can sometimes be a lot faster. All right, reading a Venn diagram with percentages. So when you see these decimals right here, they mean percentages. So Miss Bajan asked her class the following questions. How many of you know how to rollerblade? And let's say rollerblade is A and bike is B. So this is rollerblade here. All right. She put the results in a Venn diagram, determining the following. The following represent percentages. What should the sample space add up to? So if these are percentages, they should add up to 1, which is 100%, and they do. So what's the probability of B that the student knows how to bike? So we're going to add up everything. I mean, they can rollerblade and bike, but also know how to bike. So that would be 50% of the kids in the diagram. How many know how to rollerblade? So again, we add up everything in the rollerblade circle, and that's 0.7. How many know how to bike and rollerblade? So that's 0.3 in the middle. How many know how to rollerblade or bike? So rollerblade or bike means they can rollerblade, they can bike, and they can do both. So we're going to add up 0.4 plus 0.3 plus 0.2, 4, 5, 6, 7, 8, 9. So that's 90% of the kids know how to rollerblade or bike or both. All right, and then we see that complement the not simple. So how many don't know how to rollerblade and bike? Oh, how many don't know how to rollerblade or bike? So that's people who don't know how to do either. So it's the 0.1. So 10% of the kids that Miss Bayesian asked don't know how to do either. If there are 30 students in Miss Bayesian's class, how many are in each part of the diagram? Well, we're just going to multiply. So if we take 30 times 0.1, we'll get 3. So this is 3 kids. If we take 30 times 0.4, this will be 12 kids. 30 times 0.3 will be 9 kids, and 30 times 0.2 will be 6. So how many question? If you have percentages as decimals, you just multiply it by the total. And that should add up to 30, which it does. Okay, and lastly, drawing a Venn diagram. 30 students were asked if they have a cat or a dog. 20 have a dog, 15 have a cat, 60% of those that have a cat also have a dog. Draw the Venn diagram. So you do have some overlap. They're not mutually exclusive. So let's make an overlap here. Let's do cats, let's do dogs, and start in the middle. You always have to start in the middle. So to do that, it says 60% of those that have a dog also have a cat. So we want 60%, which is 0.6, of those that have a dog. So times 20, and that will give us the middle number. So 0.6 times 20. There are 12 kids that have both a cat and a dog. Now we can go from there. So you always want to start in the middle. So now let's just do how many have a dog. There are 20 students that have a dog. 12 have both, so there are 8 that just have a dog. All right, let's do cats. 15 have a cat. 12 have both, so how many just have a cat? And there are 3 students that have just a cat. And since there's 30 students total, let's subtract the inside. And we have 7 kids that don't have either a cat or a dog. All right, and then probability, we could probably skip this because we did it before, but let's take a look. What's the probability a kid has a dog? So you're going to add everything in the dog circle. 12 plus 8 is 20 out of 30, which is about 67%. What's the probability of a dog or a cat? So we're going to add everything in the middle right here. So 3 plus 12 plus 8, 23 out of 30. And I'll just leave that as a fraction, but you can change it to a decimal or percent. And how many have a dog and a cat? So that would be the middle, 12 out of 30. And again, I'll leave it, but you can change it to a decimal percent. All right, that's it. So your assignment today will be Venn diagrams on quizzes. So there'll be a live link in class, and there'll be one on Schoology as well.